morning everyone. This is the video for task 7.3D. The components used in this task are Raspberry Pi, jumper wires, ultrasonic sensor, LED, a resistor, and keyboard and a mouse and an external monitor, and lastly a charging cable for powering our Raspberry Pi. The connections in this task are as follows. The LED is connected to the 40th pin of the Raspberry Pi, and the negative terminal of the LED is connected to the ground. The GPIO, the trig and echo pins are connected to the 24th and 18th pin, and the positive VCC is connected to 3.3 volts, and the ground is connected to the ground of Raspberry Pi. Here's the code for the task. First we are importing the libraries, the GPIO library and the time library. Then we are initializing the pins for the LED, the trigger pin and echo pin. Then we are using BCM mode for this task. Then we are setting the output for the pins, and in the next line we are this task required us to use a PWM or pulse width modulation, so we are using it on an LED for changing its brightness to 0 to 100. We are starting at 0, and in the distance function, first we have set the trigger pin to true so that we can initiate the distance measurement process, and we have then used a timer to measure the distance. Then we are using echo so that the waves which are sent via the trigger will be received when by the echo, and then when the waves are received back, the timer will stop, and by this distance, by this difference between time, we will measure the distance. As we know, the speed of sound in air is 343 meters per second, and we have converted it to centimeters, so 34300, and we are dividing it by 2 because there is a to and fro motion, and returning the value of distance. Then we have used this while loop for the pulse width modulation, as firstly it will print the distance, and then it is checking if the distance is greater than 400, then the LED will not glow as x is equal to 0. Else we have used this formula so that we can make the LED glow on the terms of 0 to 100 by subtracting by using this formula. And then there is then we are adding a delay for 10 milliseconds, and then we are closing our program. As you can see, program is running and the distance is being measured accurately. Now in this system, as we bring an object in front, the LED will start to glow. As we remove it, the LED will blink off.